Okay, so good deal. So yeah, so again, just as a reminder, these are the things we're going over today. What's due, we'll go through this after the break, so you guys have a chance to finish working on it, and then these are the things that are coming up that are due. So I did want to talk really quickly about Canvas. So here's your Canvas site. And if you look at the start here, or if you go to modules, it's the same thing. You'll see some basic information about the course. But down here, module 1, there's some useful information. So the links to videos for lectures, that's a link to all the videos, starting with last class, for the class. So if you miss lecture, or if you want to review something in lecture and say, what did she say? You can kind of go through there and you kind of tell by the time spots where they are. And if you're in there and you're like, oh, I don't want this part, I want something further along, you can just kind of slide along until you get to the spot that you like. Right, so there's that. Also, there's board work PDFs. So, oh, I didn't post it? I didn't post that yet. Okay, well, I'll post it. Everything we do in class, I am supposed to post. I apparently forgot to post those. But it'll have all the information of what we did in class, and you can kind of look through that. So I'll post it before you go through those. And then also, there's exam 1, the very bottom, is the practice and the solutions to the practice. I'll hand those out in class as well, the practice exam. That's the best way to prepare for the exam, is by doing the practice exam. They're like, in this class especially, they're almost exactly the same. Right, so, I mean, obviously the numbers will be different and things like that. But they're very, very similar. So by far, the best preparation for the exam is going to be doing the practice exam. And I would suggest that you do it first, and then check your answers, so that you know, so you have a really good idea of what you know and what you don't know. Because when you know the answer, it's kind of easier to kind of work towards it, if that makes any sense. And then you think you know it when you really don't. So, you know, really make sure that you do it first and then check your answers. That'll give you the truest sense of everything. Okay. So back to this. Functions. Yes, I did want to bring up some things. Thank you for mentioning that. So here, just a couple of comments about functions. So you might get something that says evaluate at x equals 2, for example. And then I'll give you this thing. Okay, so the first thing I want to point out is you're gonna hit these things called functions. We're going to talk about that a little bit more later today, but I do want to talk about that some now. And that a function in this class is always going to be one of these things. It's going to be f, or it'll be g, or it'll be h, usually of x. When you get something like this does not mean g times x. And I know it's a little bit confusing, because usually when you see a parentheses, you think multiply. But it really, that means a function of, you have function f of x, or function g of x. How do you know the difference? Context, right? If someone says, oh, there's a kitten over there, you know by context that means they're like that place, and not they are or oh, it belongs to them, right? It's just context. Same thing with math, by context. When you see these little, if you see something g of x or h of x or f of x equals something with x in it, that's your clue that it's a function. And again, it's always going to be f or g or h in lowercase like this. And usually they'll be kind of more flowery. They'll be kind of the, you know, it'll be
Italicized?
Yeah, italicized, right? So be on the look out for them. Hopefully they'll be a little more, you know, you'll get used to them. F of x is the most common. So by far and away, f of x is going to be the one we see. So if you see f of x, it usually means function of x. So when you see that f parentheses x, that means function of f. It will never mean f times x, ever in this class. Good? And pretty much in most math classes, it will not mean that either. People very rarely use f because they know it's, it's meant saved for functions. Okay, so when you say evaluate at x equals 2, so I want to point out a few things about this. This part here, that's my y. F of x is my y. This is my y. My x, so this is really just a fancy way of saying y. I could say y equals 3x squared minus 2. You guys have seen that before, right? Y equals something, right? Yeah? So f of x is really just a fancy way of saying y. Good? So y and f of x are the same thing. So the f of x is y. X is just the little thing inside of that, inside the parentheses. Right? So remember, f of x is y. Is everyone on board with that? Yeah.
I mean, these letters are just, it could be any letter, right? It could be anything that represents an unknown, right?
Yeah, it could be. In functions, though, however,
It's always
in functions, we almost always use x and y.
Okay.
Because when we graph them on the x-axis and the y-axis.
Oh, okay.
So in functions, pretty much the by far the most common standard is y and x. Occasionally you'll see people using something else, but 95% of the time, think of it this way. And it's easier to think of it this way, and then later on, if you get something weird, you can say, well, this is really my y, and this is really my x. It's easier to do that with your brain than it is to not know where to put these. Do you know what I'm saying? So if you kind of get this settled in your head, y equals some function of x, something with x in it, then that will help you sort of navigate it. Because you've all seen this in your lives. This is something you're familiar with, right? You're sort of grounded in that concept. And like I said, 95% of things out there are this. So then when you get the oddball ones, it's easier to take them and kind of insert them into what you know already. Assimilate them that way. But yeah, so, and again, we have these x's and y's because that's, we have things, we have the x-axis, and then we have the y-axis. I guess I could talk about that briefly. Right, so
f is y.
I'm sorry?
Are you saying that f is y and x is x on this graph?
Okay, f is not y, f of x is y. Does that make sense?
What does f of x mean?
F of x, this. So this part, this guy right here, this thing right here, this means the function of x. So this is a notation that means I'm going to have a function of x. I'm going to have some formula with x in it. That's what that means.
Oh, formula.
Formula.
Oh.
Yeah, f, formula of x.
Okay.
And so formula of x is the same thing as saying y. Those two things, f of x and y, mean the same thing. It's sort of like, what's your name again?
Eric.
Eric, and what's your last name?
DeLuna?
DeLuna.
Yeah.
Someone saying Mr. DeLuna, or someone saying Eric. They both mean you.
Right.
You just have two different names. Does that kind of make sense?
Mm-hmm.
Same thing. You can formally call somebody function of x, or you can say, oh, y. They're the same name for the same thing. Two different names. Does that kind of make sense? Okay. So, again, this is the x-axis. This is the y-axis. Because if I were graphing something on a number line, would I graph it on a number line like this, or would I graph it on a number line like this? If you're graphing something just on a number line. say graph 3 on a number line, would you use this one, guys, or would you use this one? This one. That's the first one. Right, so our first one is x. X comes along first. And then people are like, well, let's have a function of x. Let's do some things. So then they create a second one. What do you do? Well, you can't go this way, so they do one this way. And so that's why this is y. This is the second one. Does that kind of make sense? So this is always x, because that's the first one we have. And then we wanted a second one to represent y, because we started having functions of x. So that's where this is always going to be the y. Yeah?
So the function is always graphed on the y.
Yeah. So x says what your value is that you're sticking in. And then so here, let me show you. Like, let's stick some stuff in for x. So the easiest thing to stick in for x, it's less than 1, it's 0. Easiest thing to stick in for x is 0. Why? Because if I stick 0 in for x, this goes away. Are you guys with me? Yeah. Okay, so if I stick 0 in for x becomes 0. Anything times 0 is what? 0. So that goes away. So that's kind of a cool thing, is whenever you stick in 0 for x, anything being multiplied, any of those parts that are something times x are 0. They go away. Because anything times x is 0. So that's super, super handy. So when x is 0, this is just y is what? -2. So does that make sense for folks? Because when I put in 0 for x, this part goes away. I'm just left with the -2. So when x is 0, y is -2. When x is 1, that's another handy one to use. Someone else mentioned 1 as a first shot. That's another good first shot, right? So here I would say when x is 1, I don't know why my thing isn't. When x is, so here, this is how I would suggest you do it. Let me do this. I'll set this down here. Just ignore that, it'll go on for a little bit. It's by some person trying to sell me something. Yeah. So whenever you have it, f of whatever equals, just go along the function. So let me rewrite this over here. It's the same thing as y equals 3x squared minus 2. It's the same thing. Okay, so I'm just gonna rewrite this, and whenever I see x, I'm just going to leave a big giant blank parentheses. Why? Because whatever goes in here for x goes in wherever all the other x's are. So this is the fail-safe, easy way of substituting for x, which you're going to be needing to do a fair amount in this class. So just write in f, and I see an x, just put a big blank parentheses. Equals 3, is everyone with me on where I'm getting the 3 from? Okay, and then I have x squared. Aha, I see an x, parentheses. So the x squared becomes parentheses squared. Everybody on board with me with this part? So I see an x squared, I'm going to put parentheses squared, and then minus 2. Good? Now, if I'm going to evaluate, I'm going to throw different things in for x. Whatever I throw in here goes in wherever these guys are. So let's try 1. I pop in 1 into there. That means there was a parentheses, 1 goes in there. Okay, so what is that? F of 1 when x is 1, right? Because remember, this is my y. So this is going to be my y. It's going to be the number that goes there. When x is 1. I know we're kind of messing with notation a little bit, but it should be a little bit confusing for folks because it's new, right? So this part, this is my y. This part equals this part. So this is my, f of 1 is my y. So whatever this is going to be my y. What's inside the parentheses, that's my x. This is my y. These parts are my y. All right, so 1 squared is just 1, times 3 is 3. 3 minus 2 is 1. So yeah, so order of operations, yeah, good point, thank you pointing that out. Order of operations. Who's heard of PEMDAS? Right, so parentheses goes first. So whatever's inside here happens first. So 1, okay, well it's 1. And then exponent. This 2 is my exponent. What's it acting on? Is it acting on the whole thing or just the parentheses?
Parentheses.
Just the parentheses. So 1 squared, that's 1. And then PEMDAS, multiplication and division. Right, multiplication and division together. So multiplication next, so 3 times 1. And then last is addition and subtraction. So subtract 2, 3 minus 2 is 1. That's how we got our 1. Okay. Let me try another one. I can duplicate this.
So when you're doing something like this and you're asked to graph it, you just start with 0 and go up to 10, or? You know?
Oh, well, I would start with 0 and I would just go up maybe 1 and 2, maybe 3, and just go up a few. And then, you're probably good, just like 3 points, maybe 4 points.
Okay, it'll tell you how many graph points
Yeah,
to make or something.
it'll tell you
like
how many
that.
points to grade.
Oh,
Yeah.
okay.
Yeah, no, go ahead,
Is
please.
it like only in engineering and stuff where it has this three-dimensional,
Oh, the
the
one that
X.
comes out, the Z.
the Z?
Right, because you have X, and then you have Y, and then sometimes they want to have a third one with some Z, which goes in and out from the board. We are not going to deal with Z's.
Oh.
There'll be no Z's in this class.
Okay.
Thank you.
We're going to have X's and we'll have Y's. That's good enough. Yeah.
Never again.
Yeah, no.
It's like
Totally.
vectors or something?
Yeah, yeah, vectors, totally, exactly. What if I can, create duplicate page. Okay, cool. So let's try another one. So I'm gonna erase these guys. And let's try, so someone give me another number. Give me another number. 3, great. Well, I might go 2 because 2 would be easier, but we can totally do 3. 3 totally works. So I'll put 3 in there. Okay, so again, this f of 3 is my, so what's my x? What's my x?
Which is 3.
X is 3. Whatever goes inside the parentheses is 3. My y is f of 3. It's this stuff over here. So I'm going to do this. So 3 squared, I'll do that first, yep. So this becomes 3 times 9
27.
minus 2,
25.
yep, 27 minus 2, so it becomes 25. When x is 3. Everybody on board?
Yeah.
You guys want to do one more? No, that's probably good enough. That's good enough. Okay, so there are some points, but you guys get the idea, yeah?
Yeah.
So those are the pieces, that's how things work. Good. So that's what I mean, when they say evaluate at x equals 2, that means that they want you to throw 2 in here and figure out what it equals. It says evaluate at x is 0, then that means the same thing. They might say evaluate, and they leave the f of 3 here. They could do this. It's possible they do something like this. Evaluate. And they give you a number in here like 2. What they're saying is, what's my x?
X is 2.
2. So I've already seen x here, put in 2 for it. And then figure out what my y is, figure out what this is. Good? Cool. All right, thanks. Thanks for asking that question, that's fabulous. I appreciate that. So I'll make it clear for all the rest of you guys. I think we might be on this one. Nope, we are not. We might be on this one. Good, all right, so we are now on this Unit 1, negative exponents and scientific notation. So get that handout out. Right, it's one that starts off with this. So you'll notice all these boxes. That will tell you kind of what unit we're in. I think there's one error with one of them, unfortunately, but Yeah, and they'll give you the title. So that kind of should help you sort of sort through stuff. When I ask for stuff, go there, because that's the easiest. Okay, so we're gonna cruise on down. We finished that, we finished that, we finished this. We finished 1A. Did we do 1B yet? I think we did do 1B, didn't we?
We did one video.
Yeah, we said it was like 320 or 21 or something like that, or something like that, I can't remember. All right, so, and we did find it in scientific and standard notation. So now we're going to look at A. So the smallest planet in the solar system is Mercury, with just a mass of just 330 million trillion metric tons. How much larger than Mercury is Earth? Give your answer in both standard notation and scientific notation. So, first of all, let's change Mercury to scientific notation. And again, remember, scientific notation, as a reminder, is where you want your decimal place after the very first non-zero, number, after the very first number, and then you're going to multiply it by 10 to the something, depending on how many places you move that decimal place over. So to get my decimal place after, I want my decimal place after the 3, right? So I'm going to want 3.30 times 10 to the something. What's that something? Well, how many places do I have to move it over? My decimal place is there. I move it over 1, 2, 3, 4, 5, 6, 7, 8 times. So it's going to be 10 to the 8th. All right, or 8.
Is this number a typo? Because this says 330 million and then it says trillion behind it.
Oh, so it's this many trillion tons. So it's really, sometimes you have 100-pound weights. Okay, so imagine I have a 100-pound weight. If I had 27 100-pound weights, that would be 27, and then that's how many 100 weights. So imagine a trillion tons. It's this many trillion tons. It's that big. So trillion tons must be some unit by which they typically measure things. So it's really this many trillion. So it's even bigger than, it's not 330 million tons. It's 330 million trillion tons. It's really big. I mean, it's a freaking planet. It's gonna be heavy, right? So think of trillion tons as a unit of measure, a very large unit of measure.
But if we go by this, then
Hold on a second. Let me
Earth
look.
is bigger.
Yes, it is. Earth is bigger.
Oh.
Yes.
I thought Pluto was so small.
Yeah, there's a dispute, but we're not dealing with Pluto. I guess what they're saying is this might have been when there's some time when Pluto was not counted as a planet because it's something. There's some rule, and they're like, well, it's not a planet because of whatever. So when I was growing up, Pluto was a planet, and then for a while there was the planet X, which was like even a 10th planet, and then all of a sudden they decided that Pluto and planet X are both not planets at all. And I don't know whether Pluto's a planet or not. Does anybody have any idea?
I think it's like a back and forth thing now.
Yeah.
Or
So,
arguing.
At this point, they're claiming that Pluto's not a planet.
It's a dwarf planet.
Yeah, so, well, I don't know. But anyway, so Mercury's a planet. We're going with Mercury. Who cares about Pluto?
Aw.
How much bigger is Mercury than Pluto? Okay, so this is my, and like someone pointed out, I should say it's this many trillion tons. That's its label, kind of in a way, right? Okay, so what was Earth again? You guys have Earth. What was it from above? I don't have it.
5.970 times 10 to the 12.
5.970 times 10 to the what?
12.
12. Okay, good. So yeah, so Earth totally kicks Mercury's ass, right? It's way bigger. How do I know? I just get 10 to the 12th versus 10 to the 8th. That's like roughly 12 to 8, that's 4. 10 to the 4th? Is that one with me? So Earth is roughly 10 to the 4th times bigger. 10 to the 4th, that's 4 zeros. 1 and 4 zeros. That's 10,000. It's 10,000 times bigger roughly. Yeah? That's our rough scientific, that's why the scientists use the scientific notation. They can figure out roughly. It's roughly 10,000 times larger. we're gonna find out exactly how much larger, because we're gonna divide. So, how much larger, how many mercuries can I get out of Earth? I'm gonna take Earth and divide it, right, because division is really repeated subtraction, and figure out how many I can keep pulling out of it. So I'm gonna take Earth, and then I'm gonna divide by, how many can I get out of it? I don't even need the extra zero, I'll leave it off. 10 to the 12th, divided by 3.30 times 10 to the 8th. Okay, so I'm going to do them separately. First I'm going to do the numbers part. I want to do the numbers part, find that, and then do this part. Do the two parts separately. Do you need your calculator? Yes. Use your phone. You all have your phone. Bust it out.
How do you know what goes on top? Because I was confused, the
Oh,
other one, the other
which
one
one?
the other way.
How much larger than Mercury is Earth? So Earth is larger. So you can put Earth on top.
In the previous question, the Earth was on the bottom.
Right, because it's how much larger is Jupiter than Earth? How much larger is Jupiter than Earth? How much larger is Earth than Mercury?
Confusing, but to put on the bottom.
Well, if you want to know how much bigger something is, then pretty much the bigger one's going to go on top.
The big one always goes on top?
If they're asking you how much larger something is, then yes. If they say how much larger, the larger one should be on top. Okay, someone said, say you're 6 foot, or how tall are you?
It's almost 6'3".
Great. Say you had a son, and your son was 3 feet tall. How much larger are you than how many times larger are you than your son? Would you take your son at 3 feet and divide by you? How much larger are you than your son? You're bigger than your son, so you should take your height divided by your son's. Or let's pick something. Oh, well, let's pick something. Okay, so when I first started working, I made $4 an hour back in the day, $4 an hour. Then, when I was in college, I got up to $16 an hour. How much more, like how many times more did I make in college than I made when I was just starting out at 15? 4 times more, right? I made 4 times more. $4 times 4 would get me to 16. How do you find that? Do you take 4 divided by 16, or do I take 16 divided by 4?
It's 4 times 16.
Right?
I mean,
But
4 times 4.
But so the question you're asking is 4 times what gives me 16, right? That's your question. So to find that, you would divide both sides by 4. You'd say 16 divided by 4 equals whatever it is I'm looking for. Does that make sense? So my question here is, here's Mercury, 3.3, times what, 10 to the 8th, times what equals the Earth. What's the Earth, 5.97? Yeah?
4.970.
Times 10 to the 12th.
Yeah.
I want to know Mercury times what gives me the Earth. So how do I find that? I divide both sides by this, then this part will go away, and the part what I'm trying to find is equal to the Earth divided by Mercury. Is that making more sense to folks? Okay, good. So let's get back to the answer. So did you guys take this first part? Did everyone do this first part?
Yes.
What did you guys get?
1.809.
1.809. Okay, great. 09, and the next one's O, so I would round this off to just 809. Is everyone kind of with me on that part? Okay. Times. Okay, so what's this other part? The green part. What's the green part? 10 to the what? So this part goes over here. The green part is 10 to the 12th divided by 10 to the 8. What do I get? Who knows this? Raise your hand if you have this number. Have it written down on your paper. What'd you guys get? So check with your neighbors. If you're not sure how to do it, check with your neighbors now.
Is
No one
it
should
10
have-
to the 4th?
Yes.
So you just
Yep.
subtract,
Yes. So remember we did this last class?
you know.
We took the upper one. Remember that we have 12 of these. We have 8 of those. So 8 of these will cancel out 8 of those. We have 4 left on top. Does that make sense? Yes, no? You have 8 of these, 8 tens down here, you have 12 tens up there. 8 of the tens will cancel out 8 of those tens. So then I have 4 left over on top. Okay. So it's 10 to the positive 4 because they're on top. That sounds bigger. And then, good. So then we also have to write it in standard notation. How do I change this to standard notation? Everyone write down what that equals in standard notation. Have you figured that out? Remember, whatever this is, that's how many times you're going to move the decimal place over. Should it become bigger or should it become smaller? It's a positive 4, so it should make your number should become bigger. So move it over 4 times in order to make it bigger.
1809.
So I have 1.809. I'm going to move it over 1, 2, 3, 4. Oh, I got to add another 0 because I don't, everyone with me? Because I don't have enough spots. So it should become 18090. Good? And again, that's trillion tons. But no, actually it's not, because they cancel out. So Earth is roughly 18,000 times bigger than Mercury. 18,000 times bigger.
So in
That's a lot.
this one, you went to 4 figures, 4 sig figs.
Oh, I could have, okay, we could have left it, we could have rounded it off to here. Do you guys want to round it off? We could round it off. If I were rounding off 1.809 to 3 decimal places, or 3 sig figs, it'd be 1. Okay, so yeah, you brought up a really good point. This is how many sig figs, guys? 4. If I round it off to 3 sig figs, what would this be? 1. So I could make it 1.81 times 10 to the 4th. So then this could be 1.8, so that'd be 1.81. And again, you still move it over 4 times. 1, 2, 3, 4. I got to add 2 zeros. Right? So you have to, and then my new decimal place would go right there. So this would be 18,100. So this is if you do 4 sig figs, is if you did 3 sig figs. It'd be right here.
So the rule in division, though, is to take the largest of the sig figs or the smallest of the sig figs?
If you're saying something's larger, then you take the larger one onto, of the sig figs?
Yeah.
The rule is you have to take the smaller of the sig figs.
Okay, the
Yeah.
smaller, so that's why.
Yeah, so it really should have been,
Good,
it should have
great.
been this.
Okay,
Yeah,
Yeah.
should have been that.
okay.
Cool. Okay. So then you should have those filled in, right, the scientific and standard notation? Okay, so now we're going to look at something slightly different. The weight of a single E. coli bacterium is that really, really small or really, really big?
Small.
Really, really small. Write this in scientific notation. Everyone write it in scientific notation. Yeah. This is the standard. This one is the scientific. Seems dry or extreme. This one just go like that, like that. So. So we do. This one usually goes right here. Right here. Right here. Right here. Right here. Right So your decimal place is going to go after the first non-zero number. So my decimal place is going to go after the 6. How many places do you have to move the decimal place over to get there?
Okay.
Right? So David, I'm going to put my decimal place right here after the first 6 between the two 6s, yeah? Is that on board? So it's going to be 6.65 times 10 to the something. Should it be negative or positive? Negative, because it's really small. And then figure out how many places you're moving the decimal place over. Count how many spots you're moving the decimal place over. Literally count them. So how many places am I moving over that decimal place?
14.
Yeah. Count how many spots I'm moving over this decimal place to get from here to there. What'd you get?
14.
How many?
14.
14? So negative 14? So everybody got? Good? And I'll do it.